Okay, in this lecture, I want to talk about the abstract syntax, abstract syntax of functions in Lattice. Right, so we already had, Lattice's abstract syntax is, expression. Then we had ident, string, const, double, all of the arithmetic stuff, all of the greater than or equal to, all of the conditional stuff. Then we had a let binding, which took in a string, an expression, and an expression. And this was the way that we bound variables, where this is the variable name, this is what we're binding it to, and then we're going to use it in the second expression. And now I want to bring in two new concepts. One, which is fundef. This is going to be the definition of a function, and it should take in a string, and an expression. And then also we'll have fun call. It's going to take in two expressions. And I'll go through exactly what we want this to mean, right? So what is fundef? Remember, in Lattice, all of our functions are anonymous functions that take in a single parameter, right? So we have it look like this, right? Function x, and then we have in our body x plus 10, something like that. And so this should translate to function def, right? Where what do we have here? Well, the string is going to be whatever the parameter name is, and the expression is just going to be the body. So this is equivalent to fundef of x, and then plus ident of x, and then const 10. Right, not too bad. Likewise, if we have nested functions, right, something like function of x is function of y, where we do x plus y. Right, this is going to be nested fundef. So the first one, we have fundef of this outer unit, right? Because we're going to take in an x, and what am I going to get out of it? Well, I'm going to get another function, which is going to be fundef, this time with y, and then the body of this, right, which is going to be plus ident of x, ident of y. Right, so this fundef, well, that is exactly what we want to be translating these definitions of functions, right? And you can see that this should make a lot of sense, right? We have really just two things available, the body and the parameter. So we have the body and the parameter. There's nothing else really much to do there. Well, what about function call? Right, we can also extend this a little bit. Right, so we could have, like if we want to name this function, let foo equal this function, then what should the right-hand side be, right? Let me try to get a little more room. This is, well, our let statement, what is the let statement? We have a string, that's the name of the variable that we're binding, right? We have whatever is going on the right-hand side of the equal sign, and of course we need something like n, and then we'll say maybe foo of 10, right? So we'll have let foo, and then this is just going to be this function def. Right, so that's all that's going on there. And then, of course, we need whatever is the body here. And what is this body? Well, it's a call to fundef. So what kind of things do you think should fit in here, right? This is going to be the name of the function that we want to call, and this is going to be the parameter. Right, the parameter could be more complex than just a 10. It could be a long string of something, right? It's an expression. Likewise, the name should be of the form ident of a string. So that's also a type of expression. So in the abstract grammar, fun call just is on two expressions. We'll see when we get to the semantics exactly how we want to, restrain what these expressions will look like. But all we really need here is, okay, so we have let foo be equal to this whole unit. And then we have a parentheses, right, because the last expression in our let statement is going to be the body of the let statement, right? What are we going to be expanding? What are we going to be evaluating after we've bound foo to this function? And in this case, it's just foo applied to 10. So it should be fun call of ident of foo, comma, and then the parameter, right? Const of 10. So that's the function call, and then this is the let closing brackets. So hopefully at this point you sort of see how we would naturally translate our concrete syntax into this abstract syntax. Maybe one more case that we haven't seen is, right, like our add to situation, and we have curried functions. Right, so if you recall, we decided to say let add to equal, it's a function that takes in an x, and what does it do? It returns a function that takes in a y, which adds x plus y. Right, and then we can call it like this, where this is the call to our original add to, right? So this is the function with x as the parameter as 10, and then that returns this other function, right? That's the square brackets, which takes in the parameter 30, and then we will add 10 plus 30. So how does this look like in fundef? Well, we'll have fundef, right? We need a string for the parameter, which is going to be x. And then we need something for the expression, right? What do we end up calling? Well, it's this internal fundef. So we have fundef of, well, a string, which is going to be y, our parameter, and then the internal, right, which is plus x, ident x plus ident y. Right, so that's the definition of it. How do we actually run the thing, though? Right, we're going to do a fun call. So let's just separate that a little bit. We'll have fun call, and what's the first thing we're going to call? We're going to call ident of add to, right? And then we have to pass in an expression, and that's this internal bit, right? And this is going to return a function, which will be the first aspect of fun call. And then we'll comma, and we'll have fun call of 30. Right, these should be consts of 10 and consts of 30, but you get what I mean. Right, so this might seem a little strange. What's really going on here? We have fun call. This ident will look up what's called a closure. That's how we're going to represent the actual functions in memory. So this is going to return the closure of this outer function, which we can pass the 10 into. And that will resolve itself to another function, which we can then fun call that function with the input of 30. So you can see how the nesting works, just like the nesting of this bit, where the square brackets are basically on the inside of these outer round brackets. In the next lecture, I'll go over the semantics of how we're going to actually make the evaluator be able to interpret these things. But this is hopefully enough of an introduction to just the abstract syntax of functions in Lattice.